uh, express delight that everybody is on that is on. It is a tremendously important topic, and we hope to make some serious headway in terms of movement towards getting a bridge between some of the disparities that exist, especially relative to some population groups who have not made entree into the arena same way that others have. And so we're very pleased that this activity is taking place, that the interest is there. I'm actually walking down the hall, meeting the new Secretary for Housing and Urban Development. She just voted, I guess. And that's what's going on.
So anybody have any questions for the Congressman right at this moment? I want to thank Senator Maddie Hunter for joining us. She's here as well. Hi, Senator Hunter. How are you today?
I'm fine, Chiama, and hello, Congressman. Thank you for doing the people's work. We'll take care of this on this end. You just take care of that in Washington.
Right on. Yeah, I just left Horrid Children's Hospital.
Okay.
They're only asking for $100 million.
Is that all?
Yeah, it's tough right now.
I know it is. I know.
It is tough, but things will get better.
Yes, sir.
So, all right, I'm about to get to the trolley, and there's going to be a lot of noise, so I will sign off.
Okay, thank you so much, Congressman.
Thank you, Congressman. Thank you.
What a member of Congress on his way to vote.
I know, right? That's right. That's right.
Makes us all
Yes. Why don't we start? I have a feeling that he'll probably join us again. Why don't we start with this video that's absolutely fascinating. And this is a video of NASA, of the recent Mars mission.
Yeah, in some respects it hurts us because
and let me find it right quick.
Yeah, so this is and I'm Karen Rugg and I'm from NASA headquarters. I'll just help Tiamia with the introduction is that we did want to share with you. I think the Congressman wanted to share to be sure that you knew about the big news out of NASA over the last few days. And that is the landing of the rover Perseverance on Mars. And if you haven't seen this, we'll see if it plays all right.
Yeah, I want to make sure I'm sharing the sound. Okay, so here we go. Can you see it? Can everyone see it?
Yes.
Yes.
Okay.
Yes.
And tell me if you can't hear it, but I think we'll be able to hear it. I'm trying to find the play. Here we go.
We are starting the straighten up and fly right maneuver, where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
application indicates chute deployed.
This is actually a
navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration
from the rover. You are now seeing the Martian sky.
30 meters per second at an altitude of about 12 kilometers from the surface of Mars.
And we've never had this view before. There's actually a camera on.
Has slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
So that little circle was the heat shield falling away.
Wow.
That the rover has a parachute, and it's just kind of, it's coming down to land on the surface.
Nav filter converge. Velocity solution 3.3 meters per second. Altitude 7.4 kilometers.
Now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers above the surface of Mars.
You can hear people clapping in the mission control room.
Continuing to descend on the parachute.
I was clapping, watching it on CNN.
Initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
And I would say if any of my other NASA colleagues have anything to add, please jump in.
The system has produced a valid solution and part of terrain relative navigation.
Priming. TBA is nominal.
We have priming of the landing engines.
Nominal means good.
Back shell set.
Current velocity is 83 meters per second at about 2.6.
It took a year, right, for it to make it
There's
there.
confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars.
Take about 6 months.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars.
Ground is coming up, ground is coming up.
Accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver.
Wow.
Sky crane maneuver has started.
So that crane is actually lowering the rover down onto the surface. The thing with the wheels on the lower left.
We're getting signals from MRO.
This is exciting. I wish I could show this to a class.
Touchdown confirmed. Perseverance safely
I
on the
can send it
surface
to
of
you if
Mars,
it's okay with
ready to
NASA.
begin seeking the signs of past life.
That was excellent.
And you can, this video is on the, I think it's probably on the homepage. It's just been getting huge, huge views at www.nasa.gov. So any of you can find this, and we just encourage you to share it with people. As I said, what's really unique is that we've never had real footage from a rover and from the lander and that whole entry descent landing mechanism. They were actually able to put cameras on. It can be difficult to do. They add weight. Sometimes they don't want to do it. But we always say the camera is the mission. And when you can actually see what's going on, it really makes a huge difference. So this was big news for us. And I think also, as we get into our presentation, a great example of aviation and space together, because the aeronautics part of NASA, or what contributes to aviation, had a role to play or has a role to play in this particular mission, which is great as well.
Well, I'm just
I have
fascinated by it.
I have
wish
a video.
that. Oh yeah, you do. I wish that we could beam ourselves up to Mars, and I can think of so many inventions that or ideas that came from Star Trek that we see manifested right now in things that we do, even the microwave, to be able to cook food instantly, and of course the flip phones. Before we move on to the presentation, does anyone else have any comments, questions about the video, especially Benjamin Juarez, the young man that's online? Do you have any comments about what you just saw?
No, not really.
He's fascinated by it.
Thank you, Mom.
That
No.
Any other comments about it before we move to the presentation about NASA, what it does, and what the opportunities might present for folks in our communities?
No, I'm excited.
Okay. But Karen, I'm going to switch over these. We'll have time to ask questions afterwards. I want to switch over
Yeah, to our slides, sure.
Yeah, and you let me know when you want me to start those.
Okay, and in the meantime, I'll introduce myself, and I'm joined this evening or late afternoon by a couple of other NASA colleagues whom you'll hear from during our talk this afternoon. I'm really enjoying seeing all the faces and seeing who's here. My name is Karen Rugg, and I work in communications, meaning telling stories and doing outreach, and also help with STEM engagement for the Aeronautics Research Mission Directorate at NASA. And I'll be telling you what that's about in a moment. And I think, so are you officially now like an aviation and space initiative? Is that what I heard, or are you?
Yes,
it's both? Okay.
We are.
All right.
So you stuck with us. I'm sorry, you just stuck with us now.
Well, I'm glad aviation is up there. You know, we have to kind of give a lift, pun intended, to the aviation and aeronautics part of NASA's story. And as I mentioned while she's prepping the slides, the Mars mission, Perseverance, I don't know if you know, has a little helicopter on board called Ingenuity. And the aeronautics, the aviation, the aerodynamics part of NASA contributed to the design of that helicopter. It should fly in about a month. They have to find a landing place for it, and it'll take a few weeks for them to get that ready, but there'll be another exciting opportunity toward the end of March when Ingenuity will actually take little flights. It's like a helicopter, it will fly vertically. And then when you watch that footage again, you see the parachute that came out for landing. That parachute was tested in our wind tunnels at some of our NASA facilities that we use. So the physics of aerodynamics, the flow of air, Mars has an atmosphere, and that's how a helicopter will be able to fly. And that's how a parachute is able to slow something down, because unlike the moon, Mars actually has an atmosphere. So we're able to do things on Mars that we can't do on the moon. So it's a really great example of the combination of flight, ideas and skills and science on Earth and also on other planets. So I just wanted to share, it's a great dual story for us. And I want to thank the Congressman for the opportunity to talk with you this evening. And, you know, I have to assume that probably a lot of you are familiar with the space part of NASA, and you might be saying, well, as an aviation initiative, why are we here? So we're going to talk to you this evening about a part of NASA you might not be as familiar with. And we're also going to show you some ways that you can engage through STEM opportunities and programs with NASA. And we'll close with some examples, some really great photos and things of students who are using those STEM opportunities and who are actually working in NASA aeronautics areas and working with us on some of our research. So we look forward to sharing all of that with you. So let's go to the next slide. And as I said before, you probably know the space side of NASA. And why are we here? Can you go to the next slide?
Yeah,
Thank you.
I'm trying to get there. I'm sorry.
Okay.
Okay, there we go.
So we're going to let you in on a little well-kept secret. NASA stands for the National Aeronautics and Space Administration. We call ourselves the first A in NASA. We don't get all the attention, but we do a lot of incredible work. And actually, NASA is built on people who learned about airplanes and did research on airplanes way back in the early 1900s. There was an organization called the NACA, the National Advisory Committee on Aeronautics, and they did a lot of groundbreaking work for aircraft, how they're shaped, how the engines work, a a lot of the early pioneers, Amelia Earhart, one of the Wright brothers, Charles Lindbergh, were members of the board of advisors of the NACA. It helped us make planes that would fly and help us get through a couple of world wars. But then in the 1950s, when Sputnik satellite was flown by the Soviet Union, the United States went, "Oh, wait, what's this whole space thing? How are we gonna work in space? How do we catch up?" And then they looked to see what already existed, and found the NACA and said, "Okay, we're going to take your people, your facilities, your research, your labs, the way that you do research. We're going to now turn your attention to space. You'll still have aeronautics. You have to, first to fly in space, you have to be able to fly through Earth's atmosphere. You have to understand the aerodynamics of flight. It's the foundation of everything." But that NACA became NASA. And I can't see everybody's hands, but I would also say, I'm assuming a lot of you are familiar with the Hidden Figures movie.
Yeah.
And the Hidden Figures book. Okay. And actually, most of those women who are profiled in the book, actually all of them, all three of them, there were four, were first human computers for the NACA. So when you read the book, most of the book is about their work for the NACA and how they achieved their degrees and their jobs. But then they transitioned over to NASA. Actually, the space part is kind of the last part of the book. So it's a great way to see and learn the timeline and the movement, and to understand that aeronautics is a real core part of NASA. And that's why there's still an aeronautics piece within the agency. We work on research to help aviation, to make aircraft cleaner, less noisy. And I will show you more about that for a second. Let's go to the next slide. So that's why we are here. We are part of NASA. We are one of 4 mission directorates. They're actually, kind of think of them like 4 different organizations within NASA. There are 4 main parts of our story. We are one of the mission directorates. We have aeronautics, then we have space technology, science, and human exploration and operations. These are the structures within NASA that get all of this work done within the agency. Next slide, please. Where do we do our work? We have NASA centers around the country. They're the ones that do the research. I'm located in Washington, D.C. at headquarters, and we're the cubicle building. We sit in cubicles and help make sure that the researchers at our field centers have the capabilities and the facilities they need to do the work. So you see the ones with the orange circles are 4 of our field centers do aeronautics research work. There's one that's somewhat close to you. That's the NASA Glenn Research Center, and that's located in Cleveland, Ohio. So that's probably that is the closest field center to where you are, please. And here's where you can see yourselves in NASA, and I'm really excited that you started out as the Aviation Initiative. I guess it's okay you added space. I can kind of understand it, so long as we're on even footing. Why it's important that you know that NASA has a section that works in aeronautics and aviation is because every time you see an airplane, or you've flown on an airplane, or when we can get back to flying on airplanes, the cargo, the products that come to you on airplanes from Amazon or all of those areas, we have developed technology on board every single U.S. aircraft and in every single control tower. Over the years, we have developed technologies, and sometimes it's knowledge, like it might be a book or a folder that helps give guidance to people who are building aircraft. We don't build airplanes, the industry does that, so we work with our partners to help make their jobs easier, vehicles safer, less noisy, more clean, and that's we're always working to improve on those main goals.
So you can just see this is some information we have online. There are a number of technologies that are on board a plane. You won't see our NASA logo on the airplane because we do this work for you, for the taxpayers, but you can kind of say, hey, you know, NASA's part of this airplane I'm flying in right now. Next slide, please.
Wow, I didn't know that.
Yeah, so as we say, NASA's with you when you fly, because we literally are. We might not be in the control tower. That's with our partners, the FAA. We work with them for years as well. We are with you when you fly. So that's what we've done to this point. Those are technologies that are on today's aircraft. Now we're working on the game changers for aircraft for the very near future. This is the really cool stuff. This is where what you learn, your jobs, your skills that you choose, what you choose to study. These are the kind of the drivers where we need the workers, we need the workforce, we need the people who can help us make this happen. Maybe we couldn't hire everybody at NASA who wants to work with NASA. However, we have so many partners who are working to make these 4 kind of game-changing things happen in aeronautics. I'll just briefly describe what they are. Starting from the top left, we have a mission to achieve quiet supersonic flight over land. The overland part is the most important part. Right now, you and I cannot get on board an aircraft and fly from, say, New York to California at supersonic speed, which would cut your travel time in half to go from coast to coast. Because when you fly supersonic speed, there are these sonic booms that are created that are very, very loud and very disruptive to people on the ground. So there's a rule, you can't do it. Military aircraft can do it, jet fighters when they're moving, but they have certain corridors and lanes that they can fly in that will not disrupt people on the ground. So we have said, there's a way, we can prove it through science and testing, there's a way you can shape the aircraft so that it doesn't make those loud booms. And we're building this experimental vehicle. It's called the X-59. It will be done next year and we'll start to fly. Yes, it's experimental. It's not something you and I would fly on, but we're working to prove that you can fly a vehicle at supersonic speed over land and not bother people on the ground. Tons of research, scientific thinking, data collection involved in this effort. Next to that on the right, what we're calling future airspace, and I talked about this a little bit before at the top of the call, is our airspace is going to have more different kinds of vehicles, doing more different kinds of missions. There'll probably be more autonomous flight. How do we work with the FAA to help take our airspace system, which is the most safe in the world, and accommodate all these new types of vehicles and missions and still have it be safe and have everybody do what they need to do safely? So we are involved in that effort as well. Right below that, because it's connected, we have a mission that's called Advanced Air Mobility. I'm sure a lot of you are familiar with the little small drones that came on, kind of popped up out of nowhere a few years ago. They can fly at low altitudes. How do you make sure that flight is safe? And there's a whole vision. If you're familiar with the Jetsons, some people on the call might be familiar with the Jetsons, but it's a future where you can, on demand, you go to an app and you have a helicopter comes to your house and you get in and you fly from one part of the city to the other to your meeting. Or you have package delivery, and that's starting to happen now. And the goal is to be able to connect that work with larger airplanes that are flying higher up and have that all happen safely as well. Huge projected industry, a lot of things that need to happen on the ground to make it happen. More vertiports, places for them to land. That's a huge effort that's fascinating. And then finally, over in the next to that, sustainable aviation. What's the next airplane that we can build, that we can help industry build, that is going to be very quiet? Maybe it uses electric power. It's got a different kind of a shape, the wings look a little bit different. So it's so much more efficient. It really helps us with emissions issues, global warming and climate change, and helps to address that area. So there are a number of technologies that have to come together to make it possible without dramatically slowing down the airplane or it not being able to fly as far. We need to keep what we have, make it more environmentally friendly. So what's that next, say, Boeing 737, kind of what the workhorse of the fleet, and something that our industry can also build and then sell around the world. So we call these our four main areas that we're working in. So this is how NASA connects with aviation. This is what we're here to contribute. So if you see yourself excited by any of these areas, these are the ways that NASA connects with aviation. I'm going to turn it over. Our next presenter will describe ways that students or folks like you can connect. Students and industry and academia can also connect with our work at NASA. So I'm going to turn it over to Joletta Patrick to introduce herself and do the next section.
All right, thank you. Can everyone hear me okay?
Yes.
Okay, awesome. You can go to the next slide. So my name is Dr. Joletta Patrick. I work in our Office of STEM Engagement, which is a unique office for NASA in the instance that we do focus on students as our primary beneficiary. And we look to engage with educators, faculty, students, and the like, all at the objective and benefit of the students.
Stop it.
For me personally, my background is engineering. I've worked at a couple of our different centers. I worked in Houston as a former flight controller for the space station program, took stretching assignments over into our STEM engagement office and worked at headquarters. And I'm currently working at 2 of the 4 aeronautics focused centers in California, which is Ames Research Center and Armstrong Flight Research Center. So I work as our director of our California Office of STEM Engagement. So I'm gonna share, as Karen noted, a couple of the different opportunities that we have in our office. For the Office of STEM Engagement, we are really funded through 4 major projects. One of those projects, and of course we live in the land of acronyms, is called Mira, and that's what you see on the slides. It's Minority University Research and Education Project. The focus for Mira is towards capacity building and student engagement for minority serving institutions. So those funds are distributed competitively through solicitations. One of the flagship programs for Mira is Mira Institutional Research Opportunity. This usually goes out in a solicitation, and it offers up to $1 million a year for around 3 to 5 years for minority serving institutions. Minority serving institutions are really defined by the Department of Education, but some of the more familiar ones are historically Black colleges and universities, which are HBCUs, as well as Hispanic serving institutions. There are at least 4 other types of minority serving.
What about PBIs?
Yes, that is predominantly Black institutions. Is also a minority serving institution.
Okay.
Yep. So they are all eligible for any opportunity that I'm reflecting here as a Mira opportunity. So with the Mira opportunities, we focus to align with the mission directorates like ARMD and put out solicitations for universities for proposed work to things like the X-59 work or any of the automated mobility work that we're doing. So currently we have 20 active awards, but the key really there is that we're looking to engage and spread the work of the mission. Another opportunity that we have, which is a new opportunity for us, which is Mira High Volume Manufacturing Supply Chain, so long name. But this has been a really great effort for us. We currently have 3 active awards. 2 are HBCUs, 1 is an HSI. I will make note for this award that we are going to be going out again with this partnership with ARMD for solicitation in August. The focus here is really just as the name is to diversify the aerospace high volume manufacturing supply chain, that ecosystem, as well as the networks, really trying to increase the interest of underrepresented minorities in aerospace high volume manufacturing entrepreneurship opportunities.
Hey, Joletta, this is Karen. Can I just jump in on this because I work with you guys on this topic? I just want to say that
absolutely.
We know that you're just the ability to build the number of vehicles that are projected to be needed and to have the supply chain, which is a huge issue, getting the parts that are needed at the time that they're needed is huge in the aviation and aerospace industry. So this is what, it's not a widget, it's not a thing, but it's a system that we know there's a challenge. If we need to be able to build all the autonomous vehicles that might be needed, new vehicles that we're not yet building in mass quantities, this is a kind of a hidden issue that we know needs to be dealt with.
Awesome. You reminded me, I know the high volume within the network is the student involvement, and just kind of going back to the Mira opportunity to identify that 25% of that funding is slated for student support. So both of these programs, the student support shows up in internships, scholarships, or educational support. So excellent programs.
Which one is that? That's the RMD or the Mira Institutional Research Opportunity?
Both of them involve student engagement. The Mira one specifically requires the 25%.
Okay, good to know.
And I'll reemphasize the high volume one is definitely well, we're going to do a projection of August. So something to look
what is
for.
that? What is that? Explain that in laywoman's terms. What is that involved? I can imagine what it involves, but explain it a little bit more for us.
Yeah, so just echoing Karen's statements a second ago, is that it really is about changing the ecosystem and creating networks as far as with the institutions and with industry, and really trying to diversify the presence of underrepresented populations as well as minority serving institutions in this specific arena of aerospace high volume manufacturing. We can always get additional information to you if needed.
Definitely. We would like to send this information out to our non-for-profit network, and we have at least 3 or 4 PBIs and Hispanic serving institutions in our congressional district.
Yeah. Okay, fantastic. I'm gonna give my unadulterated hint. I don't know. I'm gonna give you a hint. You know, the best way to kind of prepare for something that's coming out, and to be very honest, it is difficult to try to put something together once it's released. But the best way to prepare for something is really go back and look to what they put out there before. That's all public information, and we can definitely work through the channels to get that information to you. But it's all out there on the internet, and you can see how it was submitted previously, and even who the awardees were, as well as their abstracts. To me, that's always the best preparation for future solicitation.
Okay, thank you so much for that.
Sure.
We can, go ahead, continue. I'm sorry. I'm sure other people have questions, so I'll stop asking.
Okay, no problem. Next slide.
Okay.
So with this slide, we wanted to show you some of the diversity of opportunities and some of the ways that we look to inspire the next generation. Another solicitation opportunity is called Mira Aerospace Academy. So again, under the Mira umbrella, focused towards minority serving institutions. But this is a K-12 effort, but specifically focused towards middle schools. So universities propose middle school engagement. However, MAA, as we call it, has a 3-pronged approach in the sense of that it utilizes curriculum that engages students. It also has a computer lab where you can do simulations of flight and the like. And then a key component that is supported by research is a family cafe. Really just kind of making the acknowledgement that a lot of the decisions that are governed and, you know, are made by underrepresented by minorities, they really still go to their parents. Doesn't matter if their parents went to college or not, but they're going to ask their parents for advice. So we incorporate a family cafe as a part of the engagement and enrichment experience of these students. The other experience, which we call Ncas, NASA Community College Aerospace Scholars, is focused towards community college students. I really love this program because many of you know for our community colleges, that's where we meet our non-traditional students. And when you're in that non-traditional environment, you think, hey, NASA's not for me. And we're really trying our best to show them, yes, we are. Ncas starts out as an online experience. It's open to all students attending attending community colleges. Through the online experience, they complete assignments and are invited in a non-COVID well to an on-site experience at a local center. With COVID, we've been creating virtual engagement experiences for those students that have completed assignments. We find that students may come to the program not even enrolled in a STEM field, and we're seeing huge trends towards them seeking any of the STEM fields as well as aeronautics. The third initiative is really a new initiative for us, and I would definitely frame this as pilot. Many of you may be familiar with the Upward Bound program. We've partnered with 12 universities, which are HBCUs and PBIs, to really work with them during their summer and spring initiatives to deepen the STEM engagement experience. So this is just a new pilot for us. You can go to the next slide.
I see you have something there, K-12 activity. What does it mean that a kindergarten can participate in this program?
For Upward Bound?
Upward Bound, yeah.
Yeah, I think that's probably more of our generic way of saying K-12. It really is focused towards high school students on their way to college. So that's our category of K-12, even if it has a subset of that sector. But it really is focused towards, it's kind of like a bridge enrichment program for students as they head to the university.
Okay, sounds great. Okay, next slide.
Yeah, thanks. So super excited about this is that even in the midst of COVID, we've been able to still continue to offer viable internships, and I should say viable as well as paid internships. And I'm not sure why I lost breath when I tried to say paid internships. And we offer internships that have been virtual to high school students, as well as undergrad and graduate. For a high school student, they have to be the age of 16 at the time of application. For any particular term, spring, summer, or fall, a student can go into our system, which can be found at intern.nasa.gov, and apply for up to 15 different opportunities at any of our 10 NASA Center locations. So it's a really great statistically, viability of actually getting a job for the summer. I do want to highlight that March 5th is our deadline for summer internships for student applications. Students can go into the system, create an application, and once their application is created, they're able to search. They can search by center, search by topic, or even search by where they are within their matriculation through school. So definitely wanted to highlight our internship program.
Did you say they were paid?
Yes.
But do you know what the salary is or the pay is?
Oh Off the top of my head, no, but I can probably find it and put it in the chat as we continue.
Okay, should we go to the next one?
Sure, yes, please.
I bet you if I ask folks to raise their hand who know about these programs on this call, I won't get one hand raised. Will I? So thank you so much for being here.
Oh, absolutely. And we're always looking for, ways to engage like this. And here is another opportunity of engagement. One of the things that we, recognize as we went to COVID is that there, a lot of students were at home and you get bored. So we really focused on revamping our website, which is stem.nasa.gov, to have these, K4, 5, 6, 9, 12, NASA STEM at home activities for students. They're designed where parent, educator can engage with students and the like, as far as, having a hands-on STEM activity. I also want to highlight on that same row where you see K4, 5, 8, 9, 12, if you keep going to the far right where the young man looks like he's thinking, we have a specific website for Aero at Home, where you can find all of our Aero activities. So especially with an Aero and Space initiative, that is a great website to get curriculum and hands-on activities for educators as well as students. You can go to the next slide. This is probably one of my favorite slides because this is the slide to say, how do I stay connected? Just as you noted previously, hey, I didn't know about any of these things. How do I find, how do I stay in tune? This is the best way. And it's called what we call NASA Express. And I want to make note, I sign up for NASA Express. NASA Express sends out weekly emails about the various opportunities throughout our agency. They do break them down as far as K-12 type events, higher ed, university related. But if there was ever a way to really stay engaged, it is to go to nasa.gov STEM Express and sign up to receive those emails. With that, I'm going to turn it back over to Karen. If there's additional questions, I'll be looking at the chat and I'll find out your question as far as internships. And I'll turn it over to Karen.
Yeah, so Gilletta, I'll have you know, I'm going to ask Dave Berger to jump on video and say hi, just so people, he's been busy on the chat, filling in data. He's the third person on our team. I just want to have him wave and say hello. He's going to present in a few slides. When you see Dave Berger, he's legit. He's there's Dave.
Hello,
so
hello everyone. I have to post.
He's legit. He's got a meatball on. So as we affectionately call the meatball. Yeah, there we go. Right over our hearts, right over our hearts. So thanks, Dave, for keeping the chat up to going and providing some of those details. So now we're gonna walk us through, and I'm gonna pick up from Gilletta, and then myself and Dave, we're gonna show you some examples of students who are engaging with NASA through programs that Gilletta just told you about. So we're going to give you some real life examples. There are a couple of programs that we just do within Aeronautics, Research Mission Directorate, but most of our things that we have, you'll see those are examples of like the community college and Mira and internships as well. So you'll see some real folks doing work because they applied, got an internship, or they were connected through, say, a university who received a grant and they were required to do internships as a part of getting that grant, or they are part of that working team. Yeah, I see the chat, but I'm going to ignore the chat. So we're going to keep going. Next slide, please. Thank you. So yeah, just a reminder that now I'm taking you back to Aeroland. And these are our main research areas. So when we do a solicitation or do grants for research
or we have topics in our K through 12 STEM activities. They're usually around these areas because we are building the workforce for the future. Next slide, please. So this is one program that is not done by the Office of STEM Engagement. We collaborate with them. We have similar goals, but this was started by our research programs. This is called the University Leadership Initiative. And this, you can read the text. I know you guys are fast readers. We did pick out, we do annual awards. They are teams of universities and other members. I just want to point out, we had an award that went to a team that's led by the University of Illinois, Urbana-Champaign. They are the lead for that team. And then they put a team together. That's a requirement of getting this grant. They have to put a team together that can include other universities, and Chicago State, which is the PBI, is one of the universities on that team. And you can see there are other, you can see universities, then they have to have an industry partner, Boeing, and they have GE. This is one particular award, but it's a great example of what makes it unique is that the university, the principal investigator, is leading the team, and they are able to choose their research topic. Normally, when we put out, we want you guys to work on something, we're telling you what to work on. In this case, we want to create leaders and people who can work across disciplines and build a plan and set objectives, much like our projects do within NASA, and you follow the same structure. So it's a fascinating way for them to experience leading a team, to bring these different populations together, be able to talk across cultures. It's proven very successful and is very, very popular. And they're tackling topics like electric propulsion, information fusion for real-time prognostics, which has to do with the safety issue in the national airspace system, adaptive aerostructures, meaning maybe wings that can change their shape while in flight, human-robot teaming, and secure and safe autonomy. So these topics they've selected, they align though, they match up with our 4 key areas, and that's the requirement they have to do, but they can take the lead. So this is really a fantastic effort. Next slide, please. So our next example is also at the university level. This is a design challenge. It happens on an annual basis. And this is usually kind of has an engineering design focus, but we are working in systems. This is open to US universities. It's available again on an annual basis. We announce the topics in the fall, actually late summer, and then it's an abstract and a paper is what they put together. So you can see some examples here of the teams from different universities, and next to them is their design concept. So it gives them, experience working as a team and putting their ideas down on paper. And they've had topics like the one that's out right now is weather tolerant options for drones. I mean, how do you help them get, when it's a high wind and you have a little tiny light drone, how does it get to where it needs to go if the wind is blowing really hard? Self-piloted aircraft, supersonic business jet. So again, they get to learn about what we're working on in NASA. Next slide, please. Just a few pictures. Again, this is university. You'll see some other examples for other populations, but this is another kind of a cool, unique university student research challenge that we manage within the Aeronautics Directorate. And these are small teams that are led by students. And that's a difference with the University Leadership Initiative I showed you a couple slides ago. Those are led by principal investigators, the typical structure. What's unique about this research challenge is they are just teams of students. They're usually smaller, and they get a grant, but they also have to be able to crowdfund some of that money. So they get experience, kind of business and financial experience, and experience in pitching their idea.
This is how the world works these days. So these are some of the students from this effort, and these are from folks from Georgia Tech and Atlanta looking very serious in their NASA shirts. They were selected as part of the 2020 challenge, and they're looking at ways to improve airflow over an airplane's wing by being able to adjust small things on the surface attached that are needed in flight. Let's go to the next slide. Here's just another picture also from the University Student Research Challenge. This is Beth Nugent. She's also with Georgia Tech, and she's pulling out a shape memory alloy wire. I mean, this is kind of a metal structure that's able to change its shape based on the environment without our manipulating it, without our moving it. It's fascinating stuff. And she just put that through a heat cycle and heat testing. They do this work at their university, at their labs or facilities, or a partner facility. Next slide, please. This is the last photo from the University Student Research Challenge. This is a group of students. You can tell it's recent because they're all wearing masks, from Embry-Riddle Aeronautical University in Florida. That's a major university for aeronautics. And they are working on a system that could back up the aircraft's primary flight control system for drones. So that's what they've been working on. I'm going to throw it over now to Dave to take over and give you some more real life examples.
Thanks so much, Karen. If we could go to the next slide, please. So when people ask me, what does a NASA intern do? The easiest answer I give, the simplest answer I can give, and I mean this sincerely, although it sounds kind of funny, is that whatever NASA is doing, interns are doing. There's almost no aspect of any mission, any program where there's not an intern working in that area. And that includes things like getting our procedures, our engineering processes ready for our future X flights. So you saw that low boom demonstrator, that X-59 with the very long nose that is shaped specially to lower the boom so that we can have overflight hopefully without disturbing people too much. And so as an example, we have interns developing the flight control room procedures and emergency procedures so that we can be ready when that vehicle is ready to fly. Could we please go to the next slide? And we have all types of internships. So going from a single intern working with a single mentor in the past example, all the way to team internships where we're studying a new concept or a new capability, and students work as a team, each taking a lead in a different area of the project, mimicking a real NASA project, and to develop a new concept for us. And all the way to this example where we had teams working on X-59 to create a flight simulation to help us communicate to communities, to people in the United States about the X-59, and we can show them a little bit more about how it flies and its impact through these simulations. So we actually had a little bit of a challenge where we had teams at 3 different NASA Aero Centers. NASA Ames, which is shown here with the behind the very large wind tunnel. If we could go to the next slide. And NASA Ames is in Mountain View, California. And here we see interns working on graphics for their simulation submission at NASA Langley in Hampton, Virginia. And if we could go to the next slide, please. And here we have interns working at NASA Armstrong in Southern California. And all of the simulations, all the teams then had a panel of experts fly those simulations, fly them, and including our chief pilot for the X-59, Nils Larson, to fly it to give feedback on how realistic the simulation flew, so it would be ready for release to the public. If we could go to the next slide, please. Dr. Patrick Gilletta, she mentioned the Ncas program, and I just wanted to elaborate on that a little bit more. So through the Ncas program, we are able to reach many, many more students, especially targeting at community college students, than we could through just the internship alone. So that includes an online experience where the students learn all about NASA's missions. And if we could go to the next slide. It also includes an on-site component where the students form into teams and perform in a robotics competition. And here they have a NASA engineer or scientist serve as their mentor. And it is quite a 4-day experience. The students mimic, again, just like our internship, they mimic an actual NASA project where each one takes a different role, whether that's chief engineer or project manager or mechanical engineer, software engineer, marketing and communication, all different aspects of the program with a NASA mentor. But they also have other portions of that, including they hear NASA speakers, they do NASA tours. They have to present to NASA engineers of their findings. And if we go to the next slide. Where they have tours of facilities, including NASA Glenn, which is shown here. Ncas happens at all the NASA centers, including the 4 aeronautics centers. And I like to joke, it's a very long day for the students. I like to joke that we try to fit a 10-week internship into a 4-day experience. And many of the alumni from this program, the community college alumni, have gone on to NASA internships at all of the NASA centers. Many have gone on to Pathways internships and full-time careers at NASA. So if we could go to the next slide, please. Now I'd like to talk a little bit about NASA, other NASA contributions. We'll see if the slide updates.
I'm sorry.
So NASA interns design, develop, and build NASA research aircraft. Here, the student is working in the small UAS. Oh, sorry. They work in the small UAS lab, Unmanned Aerial Systems Lab, with the chief fabricator here, learning about carbon composite layups for airplanes. And you may think this is just a small example, but it's actually a full-scale Mars prototype glider that a student and a student team is working on. If we could go to the next slide, please.
Dave,
And,
is your audio
example, they're working on a small glider that would roll up into cubes. And
Dave,
yes.
your audio, could you stop your video? Your audio is really breaking up.
My apologies on that. I'd be glad to answer any questions anyone has. And with this slide, I just wanted to show that while NASA, we certainly hope that every NASA intern learns more about NASA's mission, learns more about science and engineering through their internship. We, NASA, also get major contributions back through the NASA interns. And that is evident here with this picture where you see the signatures of hundreds of NASA interns who worked on this research aircraft that was the first of its kind in stability of flying wings, and is actually signed, and now both the signature and the airplane that interns worked on is now at the Smithsonian Institution. And I'm very proud of that. I hope the interns are as well. Can we go to the next slide, please? And the NASA interns contribute to our mission, but they also help us tell our story about our mission. So here we have a NASA intern who did app programming on phones and iPads to help tell A&D's story. So they created an augmented reality app. I have to lean in, but if you look at the little screen there, you can see that it's actually projecting an X-plane floating in front of the iPad. And the intern developed the augmented reality program that we use at conferences, air shows, and also the public can just download that app onto their phone to learn more about X-planes and NASA's mission. So with that, I just hope shared a few things. I hope you can tell I'm very proud of the NASA interns and Ncas students and their contributions to NASA. And I'm going to hand it back over to Karen. Thank you.
Hi, just checking. Can you hear me okay?
Yes.
Okay, great. I know we might be hitting some bandwidth bottlenecks. So I don't know if you can you go back to go 2 slides back to the careers list. Yeah, you'll see the white background and it has words on it. So it's almost right there you go. Yeah. So I think what I'm going to leave my video off for a second just because there might be bandwidth bottlenecking. Just want you to get an idea. Oh,
sorry about that.
That's okay. As Jave was just talking about, and I think you heard a number of examples of other types of skills that are needed in aeronautics. What might your aeronautics job be? And these are just some examples of skill sets in science, engineering, technical, and mathematics, but you're going to hear my A in STEAM pop out here for a second because that's a role that I play. There are also arts and social sciences needs, people who can write, people who can design, videographer, photographers, lawyers, legal, finance, educators like our STEM personnel, training. So there are lots of ways you could find yourself in aeronautics and aerospace, as well as the STEM options as well. So lots of anything with computers.
Do you train pilots, or how do pilots? Do you train any of these individuals in these jobs, especially like pilots or any of the technical and mathematics?
We don't. And Joletta, Dr. Patrick, let me know if I'm speaking. We don't train folks. They come to us with experience. There may be some on-the-job training done through a program called Pathways. They're going from university into a NASA job. I would say we do not train pilots. We have a few research pilots or experimental aircraft pilots, and they usually come from military pilot backgrounds, sometimes commercial pilots, but a lot of our test pilots, because they're flying experimental vehicles, usually have a military background.
Yeah, Karen, I would echo the same. We don't actually train pilots, but we definitely use them. Just as noted, we have the 4 aeronautics centers or focus centers, but we also have a couple of runways. And so in some of the experimental flights or training with the astronauts, we will use pilots, but we don't actually train them as a part of the work that we do.
Mm-hmm. And we have a certain number of aircraft that are part of a fleet for NASA. Aircraft are also used for our science mission director, some of our science earth sensing missions. We use aircraft ranging from supersonic fighters that we got from the military, and we use them for our own research, to smaller general aviation aircraft. They're different sizes, you know, that fly at regular speeds. So we have kind of our own little small fleet of different kinds of vehicles, as well as pilots who can fly large or small drones. So they come to us from different backgrounds.
Can we stop sharing now? Do you have any more slides that you want to show?
I think just pop to the next one. You can just pop through that one. Just kind of the vision. This is our future city. We see this hopefully happening. And then the very last slide.
I can't wait.
Information on how you can follow our story in aeronautics on social media and on the web. Social media, it's easy. Everything's at NASA Aero. That's a great way to learn the latest. In terms of STEM and all opportunities, I do support what Dr. Patrick said in terms of the NASA Express, even our own programs, solicitations, university leadership, and those are all promoted as well through NASA Express. Thanks so much.
That was a fantastic presentation. Thank you so much. I see Mr. Jamal Malone has a question, has his hand raised. Thank you, Karen and everybody, David and the entire team, Scott, Joletta, thank you so much. It was so informational, and I learned more about it, space, and just the vision of it is outstanding. Mr. Malone, you have a question.
Thank you, Tiuma. One of the questions that I had, and I see that there was a response to it in the chat, but as the aviation and aeronautics opportunities continue to increase, are there targeted efforts for minority vendors or suppliers? I did see the link on how to do business with NASA, but as it relates to targeted programs or other more specific manufacturing or supplier type opportunities, or even facilities management. In addition to the great presentation and great information, do you have anything specific on that that you can share, aside from just the link on the website?
This is Karen. In terms of opportunities to find out about those things, for the aerospace industry and aviation as a whole, I think the best thing is, point you towards professional and industry associations. I'll pop a couple of the biggest players in the chat, and they would be avenues. I think also you would have exposure to that community and supply chain and those kinds of opportunity. Maybe as part, if you did get a grant as a university leadership initiative, or the Mira, high volume manufacturing. I think some of those opportunities have been formatted that would probably put you in touch to learn more about those opportunities. But let me, I'll put a couple of acronym names and association names you might already know about, but I'll pop them in, that those can be ways to get information as well.
Well, thank you so much for that, Karen. Any other questions out there? John, I see your hand. John?
Let me unmute myself. Thank you. Excellent presentation, highly informative. Thank you and the Congressman for putting this together. This will inspire many, many people, especially since I'm going to share this with many of my students. A suggestion for Karen and Joletta. I noticed all these different professions that you folks have in there, the training and everything else that these people go through. I noticed project engineer, administrations manager, operations manager, and so on. However, for projects of this complexity and magnitude, I think that you may want to also have a project manager, someone who supervises and oversees the whole project, understands any and all professions and skills involved, and operates as a senior project manager overseeing the whole operation. Only a suggestion. Thank you.
Any other questions out there? Anybody?
Mira, is this a kind self-serving since I teach project management at the university?
What I would like to know is, Karen, how far away are we from the, or anyone on your team, from the Jetson kind of thing? How far away are we from that? 10 years, 20 years, 50 years, 100 years?
Where are we? It's probably, you know, the thing that happens with the Jetsons is it's already underway at some level. But a Jetsons future where you've got all kinds of different vehicles, things are on demand and things are flying around, I think where you would notice it is probably about 20 years away. We're focusing now on that long view in terms of our work to identify what's needed in terms of system and operators and sensors and vehicles to help that happen safely at a dense urban environment by 2040. So right now we're identifying what's needed to make that happen by 2040, but you'll see increasing levels of that kind of activity even now, but in more urban areas and regional, it kind of grows over the years. But Jetson's about 20 years.
I have a couple of more questions. One, request, if you can send us, meaning the Congressman's office or someone on your team, a list of contractors that you work with. Maybe we can organize some type of Zoom meeting with them to answer Mr. Malone's question. I'm sure other folks have some of the same questions about subcontracting. And then the other question is about drones. Do you train folks to create drones, or is it something? How much are you guys in that industry, the drone industry, in terms of commercial and private?
So when it comes to the vehicles themselves, we do not build the vehicles. We are working on the research to help make vehicles safe, certification regulations that the builders of those vehicles will have to achieve in order to get approval to fly. And also looking at what we call a systems level approach, the system that will be needed, the handoff, the sensors, the connections to broadband, the infrastructure that will be needed to help a number of those vehicles fly safely at the same time. So when we do our tests and our research and we need some vehicles, we have a few within NASA. We have some small ones and larger ones, but we will be doing more flight tests and field tests, and we work with our partners who are building them, like Uber and Amazon and Honeywell and Joby Aviation, and those companies. They are partners of ours, and they supply vehicles and pilots especially when we need to do these demonstrations where we need more than one. We need multiple vehicles. So,
and have you received any new information from Mars recently in the last couple of days that's interesting?
I think I heard today that they have put up a new panorama where you can actually go in and you can look at every pebble if you wanted to. So they're putting stuff up every day. Actually, I was just on a call with the people from JPL, and they were on there, and they look like they're exhausted, but they're just thrilled at the same time because they're getting data. I would say every day you're going to see something. You're going to see something new.
Wow, it is so really exciting. If we don't have any other questions, I really want to thank the NASA team for joining us today on behalf of Congressman Danny Davis. It has been so fascinating, and based on the activity in the chat. You can see that people are very, very interested in it. And you gave an outstanding presentation to each and every one of you. And let's just give them a clap because we know that it was fantastic. Thank you so much for your information. I've been asked if we could share this PowerPoint. We could post it on our website if that's okay, and to send it to folks. Is that okay? Okay. Well, thank you so much on behalf of the Congressman.
I will say what I will do though. I just want to say on behalf of the speakers that I'm going to send you an updated slide that has project manager as a career.
Oh wow, we made a change already.
I can't believe that wasn't in there. I thought that it was. So thanks for the catch. I'm going to update. I'll send her one to replace the one she has now. And
are there any students on with us that might want to ask a few questions? Any students? I see. Hey, Sue Anaya, he looks young enough to be a student. Are you a student? I see you're smiling like a student. Do you have any questions?
I might have a question. I work with middle school students, and also I have contacts in collegiate education. So I am attempting to bridge or identify a program that can bridge middle school students with university students and collaborate with a Ncas program. And I feel this presentation has helped. I feel that I can delve into research and maybe bridge a program that can help these middle school students and educate them in STEM programs and have them collaborate with university students.
Thank you. I see Tiara. Chris, that was a great, I'm glad that it was very helpful for you and for others here. Tiara, sounds like Tiama, but it's Tiara. Chris.
Hi, my name is Tiara Chris. I'm a current junior high school student that's with Westinghouse College Pro. I want to know, it's like, since I'm doing like honors engineering, can that like help me boost up, like kind of boost me up and want me to like learn more about NASA?
We'll boost you up, Tiara. Go ahead, Karen, or anyone else. Joletta have a response for her. She's trying to figure out if her current instruction in engineering can be an asset to work or do an internship with NASA.
Yeah, I'll jump in. I would say definitely. I think any additional, even volunteer or extracurricular type activities that you can do in the STEM fields where you can get a different perspective and gain more knowledge is absolutely going to be helpful. The other thing that I'll make note of, which sometimes it's not common for us to think about, I really encourage you to seek assistance on selling yourselves, resume writing, art of interviewing. Some of those simplicities we don't often think about. I consider them the bridge to the actual opportunity. A lot of times our students have the skill set for the job that's noted, but we don't know how to maneuver across the bridge. So as you're doing that extracurricular activity or that AP science or that extra engineering, also seek out your English teacher and say, hey, can you help me with my resume? How do I project myself? And a lot of times that's even counterintuitive for us. We're taught to be humble, but on the resume, I need you to brag about yourself. So yeah, it will definitely help you. But I just want to kind of even push the limits on that interdisciplinary aspect of, get some resume assistance as well as the art of interviewing assistance.
What is the interview? What is the process for once you fill out the application online? What is the process? The internal process.
Correct. Great question. So a unique aspect for the government, which is different from industry, is that a lot of time, well, no, your resume is your application. There's not a secondary application process. This is, you know, very similar to our federal program as far as USA Jobs, as well as the way our intern.nasa is structured. So you really want to consider that content, and does it really convey what your skills are and what you're able to do. Along with that, your resume is what is passed on as your application to a mentor. Remember I mentioned that you can apply for up to 15 different opportunities. You're applying for an opportunity that a mentor like Dave may put out there. And Dave being one of our mentors, you know, he may receive anywhere from 5 to 15 to 30 to 100. It just totally depends on how many applications he receives. We work with the mentors to help them filter through all of the resumes. And then we really do encourage our mentors to do interviews with the students. Let's call them up. Let's talk to them. We recognize they're students. They're not gonna, you know, dot every I, cross every T, but it doesn't mean that they don't have the ability. So let's have a conversation. And it is really through that conversation or even recommendations that we make to the mentors that they come back and give us like their top 3 options. Because you're surprised, you know, it's not surprising. You're a top-notch student, you apply to 15, many people will pick you up. So we always have to check, hey, are you interested in this opportunity, or do you have another offer? And we submit the offer to the students electronically. The students have 5 business days to respond. If they don't respond, then it's rescinded, or they can accept or decline, and then you move from there.
Are you looking for students that are higher achievers, or are you looking for students that might be, you know, a John Glenn type, you know, somebody that might just be, you know, the grades might not reflect their brilliance?
Right, I do understand. So we have a minimum GPA of 3.0. But yes, I mean, do I need a 4.0? Do I need a 3.8? Can I be a 3.2? Absolutely. And I do want to also emphasize that we not only do STEM internships, but we also offer non-STEM. My office, as the Office of STEM Engagement, we've put out opportunities for students to apply to for internships. So there's STEM and non-STEM, business, you know, all those things are needed to run the agency. And so we want to create those pipelines into all those fields.
Mira, if I may.
Yes, John.
Professors by nature are there to give. And to what Joletta just said, I've authored 2 books on career success, networking and interviewing, and another one on resume writing and portfolio. I hereby am making a contribution in honor of our community to Mira, that if you folks want my book, or if you want me to offer a workshop, I'll be delighted to do it pro bono. To me,
okay, I'm gonna take you up on that, Mr. Calares.
There you go. I'll be delighted to, and both of my books, which come with a workbook, okay, may be available to you, to the organization, as a contribution of mine to folks, to the noble work you're doing. Joletta, you're doing an excellent job. Karen, excellent. Thank you.
Well, I think we're past the 5 o'clock. Thank you, Mr. Calares, and once again, thank you again on behalf of the Congressman. I am so delighted that several students joined us. We usually have these meetings at 3:30 to increase the opportunity for young people to participate, you know, after school, you know, and I'm glad that, and teachers, and I'm glad that many of them participated. We sent a fax out to about 200 schools in our district about this meeting, hoping that the principals would get a hold of it and send it out to their students via email. And I see that some of them did. So thank you, everybody. And I'll see you guys maybe at our technology meeting next week. I think it's next week. Thank you so much, everyone.
Thank you all.
Thank you, Karen, and thank you,
Thank
Scott.
you.
Thank you.
Thank you. Thank you.
Bye, everybody.
Bye-bye. Have a good one.
Thank you,
Thank you.
Senator Hunter,
Thank
for
you so
joining us.